Morning of today's presentations about tool monitoring system. Usually, shops commonly change out tools on a schedule based on experience, but tool breakage and wear can be unpredictable. Imagine if you have a part where you have to put a hole through. The first thing we do a spot drill, but then the drill comes over and then it breaks doing its work. Then we use a reamer or boring bar, then it's also going to break doing this work. And for a unattended machine, you can make hundreds or thousands of parts without even noticing. Broken or worn out tools can be a huge problem for factory owners. It can lead you to immense downtime, and it is important that such a situation be brought to light before they take place. One way of accomplishing this is to use a tool monitoring system. This presentation was made based on our Citizen Miyano B&J 51 SY6, but in most of our Citizen Miyano machine with FANUC control comes with this option as a standard. The only machine so far that I know that does not have this option is our BNA 42S because it's our basic machine. What is a tool monitoring system? It's a flow of information and system processing which help to detect the tool condition and wear of the machining components. This is a function that greatly contributes to labor savings by monitoring the estimated load torque of all of the spindles and servo motors for each tool during cutting operation. How to find this option on our FANUC control is by pressing the custom button, then scroll down and highlight number 6 and press input, or just simply type in 6 and press input. Or you can get direct access to the option by pressing the application button, which is the second button left to right. I think at least 4 times or 5 times that will get you directly to the option. There are some notes that you have to keep in mind before you even start using the tool monitoring system, which is number 1, when machining conditions are changed, conduct a new sampling. For example, coolant, oil, speeds, feeds, depth of cut, the quality of the material. Number 2 is a sampling data is standardized 100%, and the present machining status is displayed in the toll meter. We're going to talk about that later. Depending on machining condition, detection may not be possible, especially where estimated load torque variations are difficult to manifest in a cutting. For example, finish turning, finish boring, etc. Machining involving small cutting resistance such as fine drills, intermittent cutting, constant surface speed controls, G96. And number 4, tool monitor works only with G code where feeder is required. For example, G1, G32, G76. If you're executing a rapid movement, G0, machine will not detect any load. The number 1 step we have to do is turn the memory protect key switch to off position. It's a basic step that we always do when editing the program, loading new program. Every time we start a new setup, we have to do this step. Number 2 is sampling. Sampling is where most of the customers are struggling with. We get so many phone calls based on this because they're trying to skip this step, and if machine does not have any value for the current tool in use, machine will alarm out right away. So how to do the sampling page? How to do the sampling step? hit the soft button select. That will give you 3 different options: monitoring, sampling, and setting. So hit the soft key sampling. Now hit the soft key start. Once you hit start, machine will automatically give you a message letting you know that the sampling step is in progress. Then you must go to auto continuous mode and run 3 to 5 pieces. After you make the 3 to 5 pieces, you must stop the machine because it's a new setup and there's more steps to be made. Machine will automatically put values on the tool that was in use, but the values will, depending on the access, it will show over here. This application was a turning operation, so that's why I only have values on X and Z. Once you do that, to stop the sampling step, you must hit the stop soft key. You can change this value by manual input. How to do it? You go to, you press the soft button. That will give you these 4 options. Number series will allow you to jump between the offset. Plus percentage input will increase or decrease current load values in percentage. If you want to change this 500 value increase by 10%, all you gotta do is type in 10 and then press the soft button percentage plus. It will increase 10% of this current value, which would be 550 something. If you want to decrease, just do -10 and percentage plus. Plus input will incrementally increase or decrease the current load values. If you want to change it to an even number, let's say 510, just type in 2, typing -2, then plus input. But the only difference on this one is that machine will not give you a message asking you if the amount is okay. No, it will automatically do it. So you have to be careful with doing this. And input will change the value to an absolute number. So whatever number you want to put in there, just type in the number, press input, and that will change it. Clear will clear the values in case you need to redo the step, this sampling step for any reason. Why do we want to do the sampling step? Because we change the coding condition, speeds, feeds, depth of code. But we have to be careful when using this option, because once you press the soft key, it will give you 2 options, OK and cancel. OK will clear out all the values are all offset. If you have 5 tools in use and you are monitoring all the 5 tools, you're gonna see values on all of the offset. If you hit OK, it will zero out all the offset. And then this is where these 3 soft key buttons becomes handy. So you have to zero out the values each individually. Cancel will cancel the process, and it will take you back to the sampling page. Number 3 is arrangement. This is where setup conditions required for the tool is stop level and filtered and axial selection for every tool can be set up. So number 1, there's 4 pages because we have 32 offsets, but the number 1 page is related to our settings. So number 1 setting is monitoring. You can turn it on and off anytime you want by just typing 0 is off, 1 is on, but you can partially cancel this tool monitoring option by using the M code, M220, M221. Why do we want to use the M code? Based on a restriction of small drills, finish turning, but we encourage you to use it every time you use a tool call. Every time you want to have you want to use the tool for a cut, uh, we want you to use the encode so you keep all the programming in a standard way. That does not mean when you press M220, this value on monitoring will change to 0. No, it will internally partially cancel the option. Number 2, leveling format. It will generate a message once the warning percentage of the tool life is reached. Machine will not stop working until next level is reached. The range value goes from 1 to 200. A message will be generated. The numbers on the tool meter will become red and no machine alarm will be generated. But from where this machine, the machine start counting in percentage based on this value, the machine detect after you did the sampling step. This value machine recognize as 100%, machine being at 100%, and we talked about that before on the restriction we have for the tool monitoring. So no alarm will be generated. It will just give you the message letting you know that the first level has been reached. Level cycle stop. Set the level at which cycle stop. Once the level is reached, machine will stop. It will generate exactly the same message. A machine alarm will be generated. Coding tool must be inspected. Peak value must be cleared before moving forward. This is where becomes a little bit tricky because after you visually inspect the tool and based on your experience you think, oh, I think I can get more parts out of it. So there's two ways to do it. There's two ways to adjust the settings to be able to get more parts. The number one is you can adjust the level, the percentage on your current level, or you can adjust the sampling values. But what if you just keep in mind, if you change the level cycle stop percentage, it will automatically increase the tool life for the other one, but you don't know the other tools that are in the code if they're gonna last more than the turning operation, for example. So this is where I recommend you change the sampling value in percentage by using the percentage plus input. By how much? I will say let's start by 10%. That will give you more exactly the same settings. 10% is different than your setting value. And if there's more than one tool holding the same peak value, then you can adjust the setting values. That would be more accurate, I think, and more better for you to keep control of all the tools at the same time. Level cycle stop says the level at which cycle stop. Once the level is reached, machine will stop. It will generate a message. A machine alarm will be generated. Coding tool must be inspected. Peak value must be cleared before moving forward. At this time, once it reaches this level, machine will not finish the cycle. As soon as it detects the load, machine will stop. It will stop right away. So it will generate the message, my bad, a level stop. Set the level stop at which the machine stop, a message will be generated. Machine will not finish this coding cycle. It will stop as soon as it overload is detected. Peak value must be clear before moving forward. Inspect the coding tools and replace if needed. And if you believe the tool can last longer, then readjust the sampling values or the setting values. As I explained before, if you think that the tool can last longer, so you can readjust the setting or the sampling level. White level alarm is a time will be added to the detection level condition. If alarm detection time is set to be continuous, the alarm process will be executed. If coding time is less than the setting value, no message will be generated. Using default time 0 millisecond is recommended. Why do we want to use 0? Because if you have a number, this will delay the machine to generate the message, and we don't want to do that. As soon as the machine detects the overload, we want the machine to give us the message. It's very dangerous if you use a value that is not 0. Check start filter alarm detection start. This delays the time from the coding feed to start the monitoring. If this time is delayed, the detection interval will become shorter. It is possible that the moment the tool makes contact with the workpiece will no longer be able to be monitored. Usually a short value is used in this settings because of the distance of the tool before making contact with the material. For example, when we're doing a face drilling, we tell in our program we tell the machine G0 X0, but we never say go to Z0 on a rapid movement. We always stay away at least 40,000, 50,000, and for those 50,000 is where we compensate on this value. But 0 value is recommended because we want to be able to detect the load as soon as we can. So that was the number 1 page, right? So if you see on your blue section, the tool monitor setting 2 out of 4, 3 out of 4, and 4 out of 4 is because we have 32 offset. So this is where you can turn on and off the access based on our application, based on our restriction of constant surface speed control. Number search will allow you to jump between the offsets. On and off, if you can turn on and off the access to be checked when coding material, and input is a shortcut in case, for example, if you want to disable all the access on one particular offset, all you gotta do is type in 0, then hit input. That will disable all the access. If you want to have one axis on, one axis off, one axis on, one axis off, you can use binary combination. That will give you the same result. If you decide to disable any of the axes can still generate the load, but it will keep the load below the warning level. What's our warning level? Is our level informant based on 130%. You will see on the tool monitoring load meter that the axis still be generating the load, but it will keep it below the warning level. So that particular axis will never generate an alarm. Monitoring. That's our number 4 step. Since the peak value is displayed, the situation of the tool edge can be cut. The tool which reached the alarm level is displayed. Once you go to monitor the tool, every time the tool is in the cut, the bar will be growing until you see how much load is creating every tool. So once you're there, how to get to these options? You hit select. Remember, it will give you 3 options: monitoring, sampling, and settings. So you hit the monitoring pane. Number search allows you to jump between the offset. AT search, it will display automatically the tool that is currently in use. Alarm search, If there's more than one tool holding a peak value, you hit the soft button, it will take you right to the next tool holding the peak value. And peak clear clears the hill peak values. How to clear peak values? Every time the tool has a cycle stop level alarm or alarm stop level, you need to clear the peak value before the machine allows you to hit cycle start. How to do it? You must hit the soft button, be clear. That will give you two options. All these, I mean three. All these and cancel. All will clear all the peak values are all offset. And this will clear just the peak value on the tool display. Some people use it because they want to be able to see what's the whole the peak value being held in all the tools. Keep relay related with tool monitoring. Some machines like ABX, THYs, they have three head 1, head 2, and head 3. We'll see another one in here. This is a sample program. And in resume, number one step to do is turn the memory protect key switch to off position. Number two, do sampling, run 35 pieces. Number three, set up the arrangement page and turn on and off desired axes such as spindles due to the constant surface speed control restriction. Add the encode to the program and keep in mind the machining restriction, a small drill, finish turning. Number five, monitor the tool and all the steps must be done in head 1 and head 2. I say head 1 and head 2 because this example was made for a B&J, but if your machine have three systems, the step must be done on three systems. Any questions so far?
So far, no questions.
Okay, let's keep going. Tool monitoring system. This is an option on our Citizen Miyano BNX51 SMSY, but in all our Mitsubishi control, Citizen Miyano is an option. What's tool monitoring system? We already talked about that. How to find this option? By pressing the offset button and then the menu select soft key. That will give you three options: tool monitoring sampling, tool monitoring settings, tool monitoring status. Tool monitoring sampling is where we target all the load that the axes are creating. Tool monitoring settings is where we set up all our levels and timers. Tool monitoring status is where we can check the status of the tool. We have exactly the same conditions. The number one step is turn the memory protect key switch to off position, which is normal when we editing the program, doing new setup, etc. Sampling. This is where we target the load for every axis. How to do the sampling? First of all, you have to get to this page by pressing the TM soft key, then hit base measurement or base measure. That will give you, if in your message screen, that will give you a message letting you know that the sampling is in progress. Then you must go into auto continuous mode and make 35 pieces. Once you're done with the 35 pieces, stop the machine. Machine will automatically put values in wherever axis detect the load depending on the application. And to stop the sampling mode, all you gotta do is press the base measure button. Again, that will stop the sampling mode. As I say, machine will automatically put values in here for you. If you want to call any particular tool offset, all you gotta do is type in the tool number and press input and use the arrow key up and down or the tab key to move to the desired offset. In case of a row change, use the arrow key up and down to move the cursor to each tool number. Over here is where we have to keep in mind a restriction to validate or invalidate our access depending on constant surface speed control, small drilling, finish turning, uh, how to do it, how to enable or disable the access by simply pressing this button BLD/IBLD. If you see a numeric number 0 or any other than 0, the access is enabled. If you do not see any value in there, the access is disabled. The sampling reference value can be changed by manual input by using the soft button absolute and incremental. Settings. This is where we set up all our timers and levels. The number 1 is load monitoring enabled. 0 is off. Number 1 is on. We can partially cancel this option by using the M code M220, M221, which we recommend using every time. Put it in the program every time you're going to use the tool, but that does not mean once you command M220, the value will change to 0. No, it will internally do it. Load monitoring cycle. This is where we compensate when we drill, for example, when we're using a phase drilling, the 50,000 away from the part before we start feeding into the material, this is where we compensate. 0 value is recommended. Load monitoring prohibition time. Set the time to ignore the load fluctuation caused by acceleration and deceleration. We give you this option, but you have to remember that we have a condition that constant surface speed control is not good for tool monitoring system. But if you're using RPM, you might set up a value when it's got to be a special case, but 0 value is recommended. Warning display judgment time, cycle stop judgment time, alarm stop judgment time. Each individual one of those timers are related to our levels. For example, warning display judgment time is related to warning level, cycle stop judgment time to cycle stop level. But what they do is every time the tool has detected the alarm, it at the time for when the machine displayed the alarm. But if we put a value, we basically holding the machine to let us know that the tool has reached the level. So 0 value is recommended because we want to be able to see the alarm, or we want the machine to stop as soon as it detects the load. Warning level. It says the level for the warning display. If it's set to 120% and the difference from the value read from the sampling value reaches 120%, a warning is displayed. Numbers on tool monitoring status will become yellow depending on the level. No machine alarm will be generated. If you're in continuous mode, machine will be working as normal, but it will just give you the message letting you know the first level has been reached. Cycle stop level. Set the level at which the cycle stop. If it's set to 130% and If the difference from the value read from the sampling value reaches 130%, the cycle stops. Numbers on tool monitoring status will change to the corresponding alarm level. The machine alarm will be generated. Inspect the coding tools and replace if needed. If you believe the tool can last longer, readjust the sampling value or setting value. Peak value must be cleared before moving forward. In this case, machine will finish the cycle, but after it finishes the cycle, machine will stop. And you must inspect the conditions of the tool. If you think that the tool can last longer, I recommend adjusting the sampling values. It all depends. If there's more than one tool holding the same condition, then you can readjust the setting values. But if not, I highly recommend you readjust the sampling values. But how this number is never going to change. This is what the machine is at 100%. It will never change. The machine will be doing the math internally and it will start counting in percentage. How to clear the peak value? You have to press the soft key button P clear. That will give you a confirmation message asking you if you want to clear the peak value. It will give you also the two options, yes or no. If you hit no, that will cancel the process. If you hit yes, it will the load monitoring peak values of the selected tool number are clear. If there's more than one, you have to jump to the next one by simply pressing this button, alarm search. If there's more than one tool holding a peak value, hit the alarm search, press the alarm search button, and that will take you to the next one. Alarm stop level. Set the level at which the device stops due to the alarm. If it's set to 140% and if the difference from the value read from the sampling reaches 140%, the machine stops due to the alarm. Inspect the coding tool, and if you believe the tool can last longer, then readjust the sampling value or setting values. Peak value must be clear before machine allows you to reset the alarm. So if by any chance you want to hit reset and then hit cycle start, machine will not do it unless you clear the peak value. So it's like a safety. Machine is asking you, is forcing you to inspect the coding tools and clear the peak value, and you hit cycle start. So it's on your responsibility to do this step. Monitoring the current machining status with the sampling data of the tool number commanded during machining in automatic operation mode is displayed in the load meter. Some people trying to look for this option during check mode, but tool monitoring system does not work on check mode. It only works in automatic mode. In addition, the peak value is displayed. The tool number which has reached the alarm level is displayed. Every time the tool is creating the load, you will see this blue bar going up and down, and it will give you the load on your right side. You can see P value. You can check the load in there, but you can only check one tool at the time. I mean, two tools at the time, depending on the system, right? This is just a picture when using the tool monitoring step and alarm stop level. It will automatically change the color, and it will give you the message. If you disable any access, this is how you're going to see it, all gray. It will not create any load. Big selection related with these options. If you have three systems like the B and E, You're gonna see one more bit selection, sample program, and in resume, turn memory protect key switch to off position. Number 2, do the sampling, run 3 to 5 pieces. Number 3, set up the arrangement page and turn on and off desired access, such as spindles due to the constant surface speed control restriction. Add the M code to the program and keep in mind the machining restriction, small drill, finish turning, etc. Monitor the tool. Any question?
So far, no questions, Juan.
Okay, let's keep going. And lastly, the option is not available for our Citizen-Cincom M532 model. This option allows you to monitor all 3 systems in one page and a rotary spindle on a separate section, which is great. Our settings and procedures are very similar to Citizen Miyano machine, like with Mitsubishi Control. They have exactly the same settings, and tool monitoring status page it is similar, very similar, but when one tool has reached a value, they have 3 different columns on here. It will appear over here, which is great, so you can keep track of how many times the machine has alarmed out for the same reason. And I tested, I play around with it, and it's very powerful and is highly accurate. And that concludes our presentation. Thank you for attending.
Juan, I have a quick question.
Yes.
Now you were talking about the tool call. Is that actually the offset call or the actual tool call itself? Because I saw one page that showed like 80, and that would be like number of offsets available.
Offset call 80?
Well, you know, when you went back to, there was a page in the Miyano Mitsubishi, a couple pages up from there, I think. Right here, up that last page.
Yeah.
So status by tool number, it shows 1 through 80. So is that actually like, say you're using, you know, you have multiple tools in a position. So is that actually by the actual tool call position, or is it by the offset call with that tool?
It actually does only the one you're using. It does not do all the 80 because I don't think some people, all the people use all the 80 offset.
Okay, this is Jinho. I wanted to jump in. This call is offset call. I think, Jim, you're asking if you call the in program T0180.
Correct.
That's the 80. So that's the offset call.
Okay, so I just want to make sure, because especially on, well, a lot of our machines, we have multiple position holders. So we may have 3 or 4 tools in one position, and we use the separate offset calls and T-data stuff to recognize those tools, you know?
Yeah, on Miyano side is offset call, and Cincom 532, we just played a little bit. I believe it's also offset call.
Okay. I mean, I think we just got the software upgraded on our machine here, so I'm going to test that as well. But just while I was here, I figured it'd help me out a little bit.
Yep.
Oh, the other question, can you sample multiple tool positions in one sampling, the 3 to 5 pieces, or is that basically individual?
I don't understand your question.
Well, when you have to go through the setup of the tool sampling itself, so you have to run 3 to 5 pieces to basically teach it. Can you teach multiple tools at the same time, or do they have to be taught individually?
My recommendation, once you do the setup is done, let's say you use a 12 different tool, you don't want to do the sampling of one tool at a time. So once you finish the setup 100% and run through the whole your program, 3 different, I mean, let's make a 3 part, that's what they recommended. And what our system does, the number goes into the all the servo motor, including spindle motor. It picks up whatever the highest torque. It's not averaging out. So my answer is yes, we recommend do all the tool at the same time.
Okay.
Was that the question answer?
Yeah, that was basically it, because it just seems like if we had to do them individually, depending on how much
No,
we have,
we
it
don't
would take
recommend
forever.
it individually.
Yeah, okay.
Unless
Yeah, 'cause
you
the
break
examples
one
only showed
tool,
one
yeah.
at a time, so I just wasn't sure if we had to do them one at a time.